6.4 number 1. Right? Do 1a and 1b. 1a is using combinatorial reasoning as an example 1. Find the expansion of x plus y to the fourth. Well, combinatorial reasoning is really following this format. That should be a y. That's a really poorly done y. You're going to have x plus, you're going to have some coefficient times x to the fourth plus some coefficient times x to the third, y to the first plus some coefficient times x squared, y squared plus some coefficient times x to the 1, y to the third plus some coefficient times x to the 0, sorry, this would be y to the 0, x to the 0, y to the fourth. And basically, combinatorial reasoning says that you use this number and you take combinations of it to get these values, all these, all those. And so what you plug in combinatorial reasoning is you do C, combination of 4, choose 0. That is to say, get the amount of combination, or rather 4, choose 4, right? Sorry, you use, no, it is 4, choose 0. I apologize. Let me get the eraser out so I can make that neater. Basically, when your y0 term is, or when your y term, when your y exponent is 0, you're going to choose 0 possibilities, or you're going to take a choice from 0 possibilities. Wow, that's really hard to say. But you have 0 possibilities for y, so you're going to do 4, choose 0. And so you're going to do the same thing for here. When y is 1, you're going to do 4, choose 1. And y is 2 here, you're going to do 4, choose 2. And y is 3 here, you're going to do 4, choose 3. And 3, and when y is 4 here, you're going to do 4, choose 4. And that is, by the way, get ready, because this is exactly what the binomial theorem is. You just do the same format for the binomial theorem. We'll show you that in part B. But this is going to come out to 4, choose 0, which is, I'm not going to do all of these terms this lengthy, but what's 4 minus 0? Right, this is 4. Right? Yeah. And 0. Right? And that's just going to be 1. So, hopefully you guys can remember that. 4, choose 0 is just 1, x to the fourth, plus 4, choose 1, x to the third, y to the 1. This one here is going to be 4 factorial over 3 factorial, 1 factorial, which is just 4. Let me write out what I said there. 4 factorial over 3 factorial, 1 factorial. Right, that's what that would look like. And that's just going to be equal to 4. Plus some coefficient of x squared, y squared. And that's 4 factorial over 2 factorial, 2 factorial, which is going to be 4 times 3 over 2, which is 6. And then plus 4 factorial over 1 factorial, 3 factorial, which is just going to be 4 over, what is it, 4 over 1, right? So just 4, x1, y3, plus 4 factorial over 4 factorial, which is just 1, plus x to the 0, y to the fourth. And so that if you want to write that out a little neat, that's x to the fourth plus 4, x to the third, y plus 6, x squared, y squared, plus 4xy cubed, plus y to the fourth. Right? And our doing the binomial theorem is just exactly that, right? So let's do this using the binomial theorem. Well, the binomial theorem tells us that in order to get the answer to x plus y to the fourth, you can do this exact same thing. It's the same format. So I don't want to go through it all again. But if you just look at A, you do the same thing as you did in A. Coefficient of x to the fourth. For choose. You're going to do it for whatever the y coefficient is, right? So if y coefficient here is 0, there's going to be 4 choose 0. Right. Let me double check to make sure that's the correct formatting. I don't want to mix anything up here. Let's be 100% sure. The binomial theorem is that. Where is it? Yes, you use the. This 0 is going to be the y exponent. Yeah, so you're always going to do 4 choose whatever the y exponent is. So in this case, it's 4 choose 0, x to the fourth, plus 4 choose 1, x to the third, y to the 1. See how the y coefficient this k down here, right? This is nk. You see how this k down here matches the y, the exponent of the y, and then this is 4 choose 2, x squared, y squared, plus 4 choose 3, x y cubed, plus 4 choose 4, x to the 0, y to the fourth, and that's going to give you the exact same answer because it's really the same method, just given a different name. What is it? 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the fourth, right? And this, so it's the same answer. All right, that's it.